Hi everyone, my name is Mandy Waite. I'm a developer advocate for the Google Cloud Platform. Welcome to Google Developers Live.
Welcome indeed. I'm Fred Sauer, also developer advocate on the Cloud Platform. Today we have a number of questions that you've already submitted that we want to answer. But first, Mandy, you have a little presentation for us, kind of give some of the viewers who are not as familiar with App Engine an overview, and then we'll get right into your questions.
Yeah, so most people who will be on the live stream are actually people who have signed up for the App Engine Startup Pack. So welcome to everybody. Thanks for joining the program. Hopefully this will inspire you to use some more of those credits. We're going to look at some of the features of App Engine in this presentation that you may have actually overlooked, you may not have seen or may not be aware of. So we're going to dive straight into the presentation. So we've done the intros. So firstly, the startup value proposition. App Engine is a great product, but what's the real value for startups? So one of the key points, and this kind of stuff is already documented at cloud.google.com, but we really want to make a big point of these value proposition statements here. App Engine is very quick to get started with. It allows for very rapid development of applications, and that's important to startups who want to build a minimum viable product in perhaps hours, not days like they used to. They want to get their application out to market as quickly as possible. And to kind of facilitate that, Google App Engine is extremely easy to use. We give you all of the tools you need to build your applications, to test, to launch, and then to update your applications going forward. We also provide a very rich set of APIs and services which you can build your application upon, leveraging things like Mail, XMPP, and other task services in the background. Also, autoscale. People keep talking about autoscale when I mention App Engine. Immediate scalability, almost to most users of App Engine, it's almost like there's infinite scale. So you can scale as rapidly and as massively as you need to. And also, one of the final points is that you only have to pay for what you use. App Engine is free to use to get started with. You get some benefits from signing up for billing, particularly the credit pack. So you guys have all already signed up for billing. But you only pay for the resources that you use as your application grows. And here's some credits from people that have used App Engine and been successful with it. So Khan Academy offer teaching programs online, and they're very pleased with App Engine. We use their statements quite often in these talks. They feel that App Engine gives them the ability to spend all of their time developing their application and not worrying about infrastructure. Pulse in a very similar position, a quote from Greg Bayer there, that they can spend time not worrying about the things that they used to have to worry about. Google now takes care of those things for them. Just to go over very quickly some of the new features in App Engine. We update App Engine pretty much every month, so we're currently at 1.7.7. And in case you're still lagging behind a little bit, it's important to keep up to date with new updates and to look at some of the features we've introduced recently. In App Engine 1.75, we introduced cloud endpoints, which we'll talk about in more detail. Cloud messaging support, high memory instances. In 1.76, a bit of a lesser release, but we introduced task queue async methods. And if you're developing in Python, you finally got a multi-threaded development app server. In 1.77, which was released in April, that was the last release, we finally provided Java 7 support. It was previously available in the SDK. SSL support for Python, Maven support for cloud endpoints, and also we removed the minimum charge of $2.10, so you no longer have to pay anything until you actually hit your quotas. So just going to quickly go over some of those features that you may have actually missed, that may not actually be completely apparent. You may have started off with App Engine a while back and actually not kept up to date with some of the features we've introduced. Cloud endpoints is a really important feature for us. Basically what this allows you to do is to develop APIs in a way that's very similar to the way that Google develops their APIs. You can take an existing application or develop a new application and annotate your classes and methods within the application to expose those classes and methods as an API. And once you've exposed them as an API, you can discover that API. There's various utilities that we provide that allow you to get discovery documents and then to build API client libraries for your own API. With those libraries, you can then go on to build clients for Chrome, for web applications in general, for Android and for iOS. So we feel that cloud endpoints is an extremely important feature. So if you're interested in building particularly mobile backends, and when I say backends, I use it in the broader sense of the term than the way App Engine uses it. But if you're interested in building mobile backends, then you should really check out Google Cloud Endpoints. Another thing that people sometimes miss is app stats. It's not turned on by default. You can add it to your application, and you can use it for profiling your RPC calls. You can basically use it to work out where your application is spending time. Now, App Engine sockets, this was a highly sought after feature. Previously in App Engine you were not able to create sockets of your own, to create outbound sockets. We've introduced that feature. It's enabled for trusted testers at the moment, which means you have to sign up for a program and agree to do some testing and feedback with it, but it is available for you to use today. Also, we provide a search API, and again, some of these services are experimental, which means they're liable to change. Cloud Endpoints is currently also experimental. They're liable to change from release to release, but they're worth looking at now. Search API is one such feature, and that allows you to do Google-like searches across your own application data. It supports things like custom scoring, which is the ability to create algorithms for scoring the results that are returned, and also rich snippeting, which allows you to return HTML snippets of your search results with the search term highlighted in bold. And it also supports GeoSearch. So if you have the appropriate data in your application database, then you can do GeoSearch across your data. And for those of you based in the European Union, and there are several of you, many of you in fact, we also support App Engine out of European data centers. So this is great for compliance and locality, for reducing ping times and such like. You do have to sign up for a paid application for this, but you guys are already signed up for paid, so that's great. So you can use that today. Also, we have a fairly extensive and growing all of the time development stack. We have Maven support, we have Maven archetypes and plugins that you can use to deploy your applications. Jenkins is also supported in the cloud through a thing called CloudBees. Online IDE called CodeMB, which also supports App Engine. And we also have the Google plugin for Eclipse, which ties in with the SDK. And very quickly, looking at the storage options, storage is a big thing for application development. We have many different options, and the ones, we're not going to go into detail today, but you can look them up online and get more details about them. But we have unstructured data support using Google Cloud Storage and Google Drive, structured data, the App Engine data store, and also relational data using Google Cloud SQL. Very briefly covering those three options. I'm not going to actually talk about Drive today. Drive is a cloud product, but we don't generally talk about it in these particular talks. NoSQL data store. So this is the App Engine data store. It's schemaless. It supports atomic transactions and queries. This is really great for internet scale, denormalizable data sets. So really think differently. No joins when you're using this kind of NoSQL data store. And also a fairly standard Cloud SQL offering. This is really MySQL in the cloud. It's very familiar to anybody who's used MySQL before. It's fully managed and it's best really for bounded scale. We don't have high levels of scale for Cloud SQL yet, and I believe it's actually out of experimental now. And the final offering, last but not least, is Google Cloud Storage. And this is really a bucket for storing all types of unstructured data. The 5 things you really want from a data store: reliability, durability, speed, low cost and simplicity, are all kind of encapsulated in Google Cloud Storage. So you can check those options out online. Just a quick mention of Google I/O. Google I/O is going to happen next week. If you haven't got a ticket, so that's unfortunate, but you can stream the events live. You can follow up afterwards on YouTube. There's many interesting talks, many talks on the cloud platform, including App Engine. If you want to be more involved, we also have I/O Extended, and you can find out more about that from these links here. These links will be available on YouTube afterwards if you need to go back and have a look at them. So, really, now we're going to open it up for questions, and Fred and I are going to try and bounce some questions back and forth to one another.
This is my favorite part.
Your favourite part?
I do.
Is it? Okay. But you're a real App Engine expert, and I'm kind of new to App Engine, so I may struggle.
Well, listening to that presentation, I think I might dispute that.
Cool.
Since you've spent a lot of time talking already, do you maybe want to throw a question at me and get started that way?
Yeah, so we opened up a moderator page on the Google Developers Live site. So we have several questions from there. We pulled some. We may be able to get a chance to look at some of them afterwards, but we have like 20 odd questions we can go through.
Okay.
So one of them, the first one was, I want to develop a RESTful web service using Google App Engine that's consumed by my web application running in a different domain. How do I restrict the calls only to my web application? What are the best practices?
Okay. So this is a question of cross-domain or what the standards like to refer to cross-origin requests. So if you look on the W3C web pages, you'll find something called CORS, C-O-R-S, and that stands for cross-origin request source. I forget the abbreviation now. I use it too much.
Yeah, it's called CORS.
Cross-origin request sharing, I believe, what the actual abbreviation is. And basically, this is a mechanism whereby servers and browsers agree on how to communicate the domain of the website that is making the request to the server, and for the server to either grant access to that content or forbid it. And what you do is when you set up simple resources like even images in an image tag, or when you make an XML HTTP request, you can specify that request is a cross-origin request. So it's headed for a domain other than the one that the website's running on. So maybe your website's on mygreatapp.com, and the backend service that you're connecting to an App Engine is actually on mygreatbackendservice.com. And you can do that, but you have to set this extra flag in your HTML, in your JavaScript, to make the cross-origin request. And then on the server, for a GET request, there'll be an extra HTTP header coming in as the origin header. And this is an indication to the server that this request came from another origin. And right then, you can make the decision in your request handler whether or not you want to allow that request. And you do that by sending another response back, which is the access control cross-origin allow, and you can specify the domains that are allowed. If you make a post request or a put request, then the browser will do something even smarter than that. It will send what's called a pre-flight request, and will send a request in advance and get permission before it actually does the submission. So the short answer to this question is there are existing standards to do this. It's very easy to do. Just look up CORS, C-O-R-S, and implement the details there. You can do that in your request handler in your HTML app, and you should be good to go.
Excellent. Wow. You got one for me there?
I do.
Is it an easy one?
Hopefully come up with a shorter answer than mine. Maybe we should have started with an easier one. Let's see. So how viable or recommended would it be to build a backend service for mobile apps around Google Cloud endpoints?
Right, okay. So I think really that's probably the biggest use case for cloud endpoints, building mobile backends. And when we say backends, we're kind of, again, we're talking about the general sense of it rather than the App Engine sense of backends.
Yep.
If you want to build an application that will provide resources and services that are consumed by mobile devices, then cloud endpoints will do that for you out of the box. I think pretty much we covered most of that in the slides, but the documentation is pretty extensive, both for Java and for Python. So if you want to find out more about how to use cloud endpoints, you can check that out. And there's also a Google I/O talk last year, wasn't there, when it was launched?
There was, yes.
Yeah, so you can actually get a lot of information from looking at the Google I/O sessions from previous years.
Very good.
Yeah.
All right, your turn.
My turn. Okay, so last week, maybe that was last week or could have been written last week.
Okay.
Last week I had to rename an entity kind name for Google App Engine Java. I had to write one-time code in my application to duplicate each entity to the new kind name, delete old entities, then remove the one-time code and redeploy the application. Is there an easier way of doing this?
I think this is a little bit of a longer question, but I think the person who asked it is actually on the right track on how to do this. So first, let me contrast this with how you would do things in a relational database world, where you have a fixed schema for your database. So if you have, for example, a table in a relational database that is called customer, and you decide for whatever reason you want to restructure that, and you want to call it customer 2. What you would actually have to do is you would have to declare a maintenance window. You'd have to take the website down, and you would then perform the database maintenance. You would rename that table, which locks the entire table and all data in it. You would modify the code in the application server. You'd bring everything back up, and maybe half an hour later, maybe a few hours later, you'd be up and running. And that was maybe acceptable a number of years ago when websites regularly went under maintenance and a lot of systems were just 8 to 5. But now we live in a world where everyone's connected to the internet. It's always 5 o'clock somewhere. Everyone needs to get to your site all the time. And so what you really want is a system where you can make changes while the system's up and running. And part of the question actually has the answer here on how you do this. So the specific question was, how do I rename an entity? But you can generalize the question. What if you wanted to add new required properties to a particular entity in the data store? Or you wanted to restructure. You're going from 3 separate entities and you're kind of combining them into this new data structure where you put everything in one entity. And these are common refactorings that will happen with your application. And so the way to do this is to think about this live system that's always handling transactions. And it's actually sort of a 3-step process. In the first step, what you want to do is change your application so that anytime that you write out an entity, you're writing it out in the new format or with the new entity name, with the new properties, the new constraints. But at the same time, that every time you do a read, you first look for the new kind of entity, and if you don't find it, you look for the old kind. And you deploy that, and as soon as you deploy that, your application will slowly begin migrating data. Any user that logs in and touches their data, those entities, those rows in the data store will begin to get migrated. And now actually you're in a perfectly happy state. Your application will continue to function. There's a little bit of extra read overhead for people as they're migrating, but you now have all the time in the world to make the full migration happen. You're still serving live traffic. And now, depending on what you want to do, you can either say, well, just leave it like that, but oftentimes that extra code there is complexity you don't want, and you might want to get rid of that. And so what you do is then you run what we call a map reduce, but you essentially iterate over all the entities of that old kind in the data store, and you just touch each one. And you can do that in application logic. And as soon as you touch each one, it gets migrated to the new structure. And you can take an hour to do that, a day. You can take weeks or months, really however long it takes. And once everything's been migrated, then you go back into your application and you just remove that extra code in the read handler, and your app's migrated. And many developers have many of these migrations kind of in place at once. They might introduce a few migrations incrementally, and then maybe once a quarter do a cleanup and get rid of some of that code. It's not the case that you have to migrate everything in a short window. Think about doing things live and in real time.
Wow, okay, that's cool. You got one for me?
Yes. All right, here's a developer who is a little bit conscious about the bill at the end of the day. He says, each day I fight to really save every penny on App Engine.
We all. Yeah.
We all do. How could you help us better profile our applications? App stats is something you actually mentioned. He thinks is a little bit hard to use. And what's the best way to kind of tune your application?
Oh, interesting question. Okay, so yeah, we mentioned app stats earlier. I think we've kind of discussed this before. We think that app stats is still probably the way to go. It's built into the platform already, no external tooling needed. So it's there ready to go. It will only profile your RPCs. It won't tell you where all of the hotspots in your code are, but it will definitely give you a really good indication about what your application is spending its time doing, particularly in terms of RPC calls, calls to the data store that includes as well. It's very easy to get up and running as well, so we're not sure if it's difficult for you to actually get up and running and using it, or whether it's difficult for you to actually get anything meaningful from it. But generally, it's fairly easy for both Java and for Python to get up and running with AppStats. To get access to the console, so it provides a custom console that you can have access to, which you can actually include in your basic admin console. And once you have that available to you, you can look at your RPCs, you can look at each one of your requests, open up the request and then drill down into the request to see where you're spending your time. And even then with Python, and I'm sure this is available with Java, but with Python you can actually look at the code that actually generated the RPC call.
Yeah, in Python you have stack traces, that's
exactly,
right.
Yeah. So with Python you can actually dive straight into where the code is that's actually causing your long RPC calls and actually modify them, redeploy the application and see what result you get. So that's really cool. So I think we'd recommend using AppStats, and definitely for RPCs. I'm not really familiar with any other profilers for App Engine, although I do think that Khan Academy actually produced a profiler. Ben Kamen's may have done, so probably worth looking into.
Yeah, check out Ben Kamen's blog. He does have a Python profiler with some nice UI widgets that tell you about the loading performance of your site. To kind of finish up on the AppStats, I think what some of our users sometimes run into is they feel like all the information that AppStats provides is really overwhelming, and it's good maybe to take a step back and one of the things that AppStats provides that I really enjoy looking at is there's these timeline graphs that kind of give you a breakdown of the RPCs visually, and 99% of the time when I'm using AppStats, I only look at the graphs. Right. There's a whole page through of stack traces and debugging information and data that's being sent back and forth. Almost everything related to performance of your application you can find just by looking at the graph. You can see whether you have data store reads that are staircased all sequentially behind one another, or whether they're happening in parallel. You can see that you're making a memcache call and then a data store call, which tells you there's a memcache miss, right? So really just getting comfortable with those graphs, I think, will provide most of the value with very little effort.
Okay. Would you recommend it for running on production as well?
I do, but depending on the traffic of your site, if you only have a few requests per second, then yeah, sure, run it. If you're doing a lot of traffic, what we recommend is that you either deploy another version in production that you hit. So you can say version.yourappid.appspot.com and access that directly. And that way you don't have all the data from all the requests from all your users kind of piling on top of each other, but you can very carefully just poke at your application and say, I'm going to do this one request here, and then I want to see the AppStats profile. We've even had people with like mobile clients, they'll have a couple of users that report performance problems, and they'll change their application to kind of send down a ping to those users and say, okay, this mobile client should connect to a different backend name. And then those users are kind of isolated on their own version, where you can kind of do diagnostics. Maybe you can enable some traces, you can enable AppStats, and then when everything's all good, you tell the clients to kind of go back to the original version.
Okay,
so yeah, a lot of ways to utilize that tool.
Yeah, definitely. Okay, well, that's good. Hopefully that answered the question. So one for you.
Okay.
Any suggestions on how to simply move data from the live server to development server and vice versa?
Sure. We have in the App Engine admin console, there's a data store backup feature, and it allows you to create a snapshot of your database. And those snapshots can be placed into Google Cloud Storage. So it's just a very large file that you can then download. You can store it offline, but you can also restore that backup to another app ID, and you can select actually which kinds get backed up.
Okay. Right.
So that's a great way to copy data between instances. If you have like production, a QA environment, and you need to get like another snapshot of data. It's pretty common. Or if you have been working really hard for months in the development server and you have all this configuration data, maybe you want to just take those kinds, grab a backup of that, and restore that and play that back essentially onto the production server.
Well, sounds easy. Okay.
Yeah.
Excellent.
Okay.
Okay.
Okay, for you. Let's see. I need a testing strategy of App Engine applications, as the SDK doesn't implement all the services exactly the way that the production environment does.
Okay.
Do you have any insight about how to test our applications, taking into account some of those differences?
Yeah, so I guess testing, there's a lot of ways to do testing. There's a lot of levels you can do testing. You can do unit testing, functional testing, integration testing. Development testing is pretty important with App Engine. You really probably don't want to deploy an untested version of our application and replace the current version that's working really well with one that's not been tested particularly extensively. So, as always, when testing in the development environment, it's probably important to mock services that you can't actually access directly.
Sure.
So in this case, if there are any shortfalls in what the development server offers over what App Engine offers itself, then you will probably want to mock that. Okay. So that would be the same with accessing another API that you don't want to access from development. You may just mock that service up so you can actually get reasonable results from making calls to that service. So you would probably do the same with App Engine as well, any App Engine services that are missing. And then beyond that, really there's lots of different options for testing. Once you've deployed the application, you may, as Fred's already mentioned, you may deploy it to a different app version.
Yep.
And then you may use traffic splitting. So App Engine has this feature called traffic splitting that allows you to incrementally direct traffic towards new versions of your app. So you can actually test it in isolation to a degree, only pushing a small amount of traffic to it initially and then slowly migrating all of the traffic over it as you get more confident in the application's performance. And again, also that other kinds of testing, load testing and such like, you don't really want to do load testing on a production application. So you would probably need to build a different version of your application and deploy that and do your testing on that particular version of your application. You're also likely to need data as well, so you need to probably have a representative set of sample data that you can deploy your application. Because it's, if you have an empty data store, it's not really going to give you exactly the same kind of results that your production application would do. So you probably want to define a set of data that you can actually populate into your application initially to do the testing with.
Yep, those are very, very good points. The one thing that bites people a lot of times when they're testing in a different application ID, or even on their production application before they launch, is people will not use representative workloads.
Right.
So they'll, instead of creating, say, 1,000 unique accounts, which is sometimes tricky to do, they'll say, okay, we'll take 10 accounts and we'll have each one log in 100 times, all running concurrently. And those access patterns actually change kind of the way the data is utilized, and you don't get very representative results there. So you already talked about making sure that you have some good sample data there, making sure you have good representative requests and users logging in is kind of just as important. Right. In any case, as much as you can kind of take the production environment that you expect and replicate it, the closer you get, the closer your results are going to match, obviously.
Okay. So you can use tools as well, like Selenium and JMeter, those kind of things for load testing.
Absolutely.
The same kind of tools you would use for any kind of web application to generate tests. And they generate representative workloads, believe me.
They do. Just watch out that you're not testing from one machine that just doesn't have a big enough network connection.
Yeah, don't talk to me about client side, because if your client can't handle the load, then you're never going to actually load up the server the way you think you are. So you need to make sure you can actually generate the load correctly. You're not falling over lack of client resources as well when you're testing. I
guess you can always get a few instances on Compute Engine. There's some capacity there.
That's interesting, that's a good idea. Yeah.
Nice big pipe of data. Let's see, where do we leave off?
I think I've got one for you, All right, could you provide us with state-of-the-art database model designs? Oh, okay, that's a big ask. Things like a CRM database model, a bookshelf, an eBay kind of application.
Okay. It sounds to me like the person asking the question is kind of looking for sample models, sample applications, like And I hear kind of the question behind the question, which is, how do I go about modeling an e-commerce site, a CRM site, in this non-relational, NoSQL world?
Right.
I want to build an application that can handle tremendous scale, but you've kind of swapped the tools out for me. I'm used to doing development on a SQL database, relational. I know how that works, but I know that that doesn't scale. So help me switch.
Right.
I think it's difficult to come up with samples that fit every single vertical, but there are some general things that we can say about the way you do data modeling, and really it's sort of kind of changing some of your habits and some of the things that you were taught maybe from the beginning working with relational databases. So one of the kind of the first tenets when you're building a relational database model is everything needs to be normalized. No data duplicated. It's typical in an order entry system to have 5, 6, 7, 10, 12 different tables that every time you want to do a query and find out what the orders are, you have to join all these tables at runtime and select your results. So you might have a table that has items in it, and it has item description, item price, and some other information. Then you have an order lines, which connects to an order header. You have order line details. It goes on and on. And this is a really good way of allowing you at runtime the flexibility to really join any amount of data with any other amount of data, which is what relational databases were built for. But in a very scalable world, what you want is actually that if you and I both make a request to our website and we're both interacting with the service, what we want is for your queries and my queries to essentially be able to be handled by different parts of the infrastructure. Okay. So it's a distributed platform, and the way to do that is to sort of isolate your data from my data. And that means what we don't want is for, if I'm pulling up a list of my orders and you're pulling up a list of your orders, we don't want to both be going to the same table and kind of running into each other. We also don't want to take a lot of time at runtime kind of collecting the data. We in distributed systems, what you like to do is kind of amortize the costs, spread out the costs, and do the costs at write time. So when we write the data, we might do some deduplication, so what you would call denormalization. So it's quite common in App Engine apps for entities to have properties with string values. So rather than have an item key on your item details page, you would actually have like the actual item code or the actual description. If you're putting together, let's say, countries, you have a kind that stores addresses and you need countries. In App Engine, you would actually just put the country code or even the full country name in every single entity. And you should kind of resist that urge to say, oh, I don't want the duplication of data, I don't want to pay for the extra storage. What you're really doing is you're separating your data and my data and making it very efficient to handle very large number of requests. There's kind of more best practices, but the first one that you kind of want to think about is denormalization is not a bad thing. Yeah. It's actually something you should really just embrace and think about. Just pick two users and imagine that they're both doing kind of the same thing in your application. How can you make it so that the entities that you're touching and the entities that I'm touching are different? Because as soon as they're separated from each other, then the Google App Engine infrastructure, the data store, can put those entities on different physical hardware, different machines, and now we can add a third user, a fourth user, a fifth user. We can have 100,000 users. It really doesn't matter how big we scale up, because each user is accessing a different part of the system. Wow. So there's kind of a lot to grasp if you're coming from a SQL environment, but once you play around with it for a little while, it's really freeing to say, I really don't care how many users show up on my doorstep tomorrow. I can handle 1,000 users, 1,000,000 users, 1,000,000,000 users. It's really independent of scale. And that's what the App Engine Data Store provides, is performance that's independent of the amount of data that's stored.
Yeah. Excellent. Oh, that's really good advice. So, okay.
All right, so Sorry for the long answer there.
No, I think it's the kind of question that deserves a long answer.
Yeah, it's a common question, so it's fair to spend a little bit of time.
A lot of people moving from the traditional relational database world to the NoSQL type world.
Yep. Oh, and we should say if you do want a relational system, you have a limited number of users. You're building a corporate application. You only know you'll need the existing performance. You can use Google Cloud SQL.
Yeah.
It's a MySQL database, runs in the cloud, managed for you, no headaches, and you get all the traditional kind of performance trade-offs and benefits. So that's still an option.
Yep.
All right, next question for you.
Okay.
Any optimization recommendations for e-commerce website with 2 million visits per month running on App Engine Python?
Wow, okay. How long have we got? Optimization recommendation. I guess what we want to optimize for is probably the important thing here. I mean, we want to optimize for performance, for load, for latency, for costs. Cost is an important consideration when it comes to cloud applications as well. And balancing cost and performance is massively important. So I think what probably I'm probably going to step back on this one a little bit and say the best thing to do is to read the resources that are available in the documentation. So we have a couple of really, really good pages on the App Engine documentation site. One is called Managing Resources.
Yes, my favorite one.
That's Fred's favorite one. Whenever I ask him a question, he says, "Have you read Managing Resources?" And I say, "Oh." So I go off and read Managing Resources, and I say, "Yeah, I found the answer." So Managing Resources is great. It tells you how to manage your instances, manage bandwidth, manage concurrency, those kind of things. So that is an excellent resource. There's also a performance-related resource on the same site. I think they're in the same section. Probably one leads into the other, and that will give you hints on performance. Often optimization and performance are kind of related, very married together in a lot of ways. So you can take those tips as one big set of tips, and you'll find really good information about how to optimize your application. If it's about cost, again, I think also Managing Resources also talks about how to look at your quotas and such like, and where you're incurring your costs.
Yep.
And also, coming back to AppStats as well, AppStats is another really good essential tool for looking at where you're spending your time in your application. So if you're concerned about latency, taking too long to respond to your users, then you can do some analysis with AppStats to find out where you're spending your time and maybe tune your application to spend less time doing those RPCs.
Okay.
Does that sound good?
Yeah, I love the Managing Resources article. If you just do a web search for App Engine Managing Resources, you'll probably hit that article in our docs. And think of it as a checklist. It doesn't tell you exactly everything to do, but it's a checklist of think about this, and you can go through each one, and you know your application best. You can tune it. If you just want what's the one thing I need to do that I may not be doing that's going to give me the biggest benefit, I'd say turn on Memcache. And some of you can get that for free. If you're using, in Python, the NDB API, or in Java, if you're using Objectify, which is a third-party kind of ORM layer, they both have Memcache built in. So anytime you write or read from the data store, it's checking Memcache. Can save you a lot of data store operations, and it won't cost you a single line of code.
Wow, fantastic. So use Memcache.
Use Memcache.
Amazing.
If you're not using Memcache, use Memcache.
Maybe I should just have to use Memcache. Okay, so I got one for you.
Okay.
Another performance. So what is the performance difference between GAE Python, GAE Java, and GAE Go?
Okay.
3 different runtimes.
Fair question. This is actually one that comes up a lot. It's a question that I try at first not to answer,
right.
And then I'm happy to give an answer. But I'd like to start out and say there are subtle differences between the 3 different runtime environments. Python, if you write any application in Python versus Java versus Go, there are some things that work better in one language versus another. What's probably much more important for your application, for your service that you're running, is what your developers know and where they're going to be productive. So if you have a Python shop, everyone knows Python really well, and there's 1 or 2 guys that know a little bit of Java. Even if Java were slightly better for your application, you're going to be much more productive, building in Python. So you should do that, and the same goes the other way around. Having said that, if all things were equal, if you hadn't hired any development staff yet, or you could pick any language, or you just want to learn something new, there are some trade-offs to make, and maybe you should look at kind of the complexity of the product that you're building and how long it's going to last. Python is a scripting language, tends to be a little more productive for people prototyping, iterating in small teams, kind of working together, lets you be very agile. You can do things very quickly. If on the other hand you're building a product and you have a very large development team or very complex code base, you're doing a lot of refactoring, and you could use some help from tools that can kind of refactor your code, do static analysis, then Java is probably a language that's more productive.
Right.
And if you want to do something that's really performance sensitive and you want to kind of build with the stuff that Googlers are building on, I would seriously check out the Go runtime.
Right.
There's some really pleasing results there. Having said that, that's an experimental runtime still.
Yep.
So if you're building a production app right now, probably Java or Python.
Okay.
And pick the one you'll be in productive.
So retraining your Java developers to program in Go is probably not the best way to get performance?
Unless that's what motivates them, and for some people, a new language is the thing that wakes them up in the morning, more so than a cup of coffee.
Yeah.
For other people, it's being able to be productive and hit the ground running.
Excellent. Okay. Well, good advice.
Okay. Let's shoot one back at you here. Can I pre-populate the data store? Is there a front end to add, remove, or update entries in the data store?
Okay, so now I'm going to punt this one a little bit because we discussed this one yesterday, and we talked about some things, some articles that have been published about doing this very thing, and so I'd like to actually talk to you about that and ask you, and bounce the question back to you and ask what you feel is the best way to pre-populate.
I think the answer depends a little bit. If you have some data on your client, like on your desktop, maybe there's some legacy data that you need to import, some configuration data that you want to do programmatically. The development server, the SDK, does have a little tool for uploading data.
Okay.
That works fine for kind of small scale, and that's a tool that's been around for a long time. Probably what you want to do, if you're doing anything larger than kind of trivial operations, is just create a cloud endpoints application or version of your app.
Okay.
That doesn't mean you have to build your entire service around it,
Right.
but maybe this is an administrative gateway, or this is a way that mobile clients kind of upload data to your application.
Okay.
Cloud endpoints is a great, easy way to create an API,
Yep.
And will automatically generate client libraries for Android, for iOS, for HTML5.
Yep.
And from any of those three clients, you can make your calls to the server side.
Okay.
If you're doing Python, a colleague of ours, Danny Hermes, has a pretty cool project called Cloud Endpoints Proto Data Store.
Okay.
And or maybe it's Endpoints Proto Data Store. But it's an application where you essentially define your Python data store models, and then you just swap out the class name that you're inheriting from, and then all your classes magically turn into Cloud Endpoints.
Oh, wow.
And so you can make calls like insert entities into the data store, remove them, do queries, all really easy. So that's probably the way that I would go. And then there's maybe one more trick up your sleeve. The SDK has a thing called a remote API, remote underscore API.
Okay.
And it's a way for the development server to essentially proxy its data store memcache requests to the production environment.
Right. Okay.
So what you do is you deploy a special version of your app with just like a one-line config flag that says enable remote API.
Yep.
And then you can run your code locally as if you're connected to the data store, but everything's being proxied to the cloud for you.
Okay.
So that's another kind of neat trick for migrating data in the cloud. Or it's a great way to do debugging. You connect to your production or staging environment, and you can kind of sort of interact with it while you're in a Python kind of console. You have your real data models, but you're looking at your real data.
Excellent. Okay. See, I would not have been able to come up with that answer. So I'll let you ask me another one now, because I think I have more questions for you than you have for me. So.
Okay. Let's see. Startup times for App Engine Java are pretty high for my application, around 30 seconds. And that is actually pretty high. And Java apps in general, even with reserved instances that we feel are underutilized, we're still getting warm-up requests. Any advice?
Yeah, so I think, again, this is going to be something that's going to be covered quite extensively in Google I/O. We have a talk, Matt Stevenson's going to be giving a talk on auto-scaling Java. Yeah. So that talk is likely to cover much of that. And Matt Stevenson also, with one of our other guys from Cloud Solutions, Wally Yao, he wrote an article that's published on the App Engine developers documentation site for managing optimization of starting up Spring applications. And often we find that it's Spring applications that really take the longest time to start. There's a lot of libraries involved, there's a lot of scanning of classes and such like that goes on automatically with Spring when it starts up, and that can lead to quite long load times. I think, as I suspect, this is probably likely to be a Spring issue. At the same time, I mean, there's also the possibility that you're loading libraries that you may not need immediately, and you may want to actually look at lazy loading those, loading them in the background as opposed to actually loading them as your instance starts. Anything you can do to minimize the amount of time it takes to start the application is good. And really, I think that's the key to handling things like startup requests, things that will cause a new instance to start, is basically just to minimize the time it takes to load your application initially. Only load what you need, lazy load everything. Don't load things you don't need to load, and also make sure if you're using Spring that you follow the device in the Google I/O token and in that particular document on the website. That will minimize your startup times, and you won't be so worried about startup requests and things that actually load a new instance, because they won't take so long to do.
Yep. All very good advice. So yeah, definitely check out the Google I/O talk. All the talks at I/O are going to be recorded, so we can check those out. Talk's happening next week, so that's a great resource.
That's on Wednesday, by the way. So are they live streamed?
Some of the talks are.
Some of the talks are live streamed, yeah. Okay.
I'm not sure if Matt's talk is live streamed, but you'll be able to catch it pretty soon.
Yeah.
Maybe something just say a little bit more general about App Engine Java. Especially these Spring apps or applications that have these big frameworks and long loading times. So one way to think about this is the way that we've been building application servers for many years has been in an environment where you would spin up, say 5 application servers, and these would be big servers that would sit on a rack somewhere, and they would take several minutes to kind of boot up, do all the memory checks, right? Machine would load up, it would load the application server software, then it would load the specific applications, and that whole process could take 10, 20 minutes sometimes. But then those servers, they would run for weeks or months or however long they needed to run. And in that environment, what you actually want to do is kind of do all the expensive work up front when you're loading the application, because you're only going to do that one time, and then you're going to have long-lived servers. App Engine tries to really kind of fundamentally deal with applications in a different way. When we want to scale up very quickly to handle an increase in traffic to your website, or when we want to scale down because there's a little bit less traffic coming in, we really need the ability to quickly spin up new instances of your application and then spin them back down kind of at a moment's notice. And so App Engine is kind of optimized around apps that have a very short startup time. Ideally it's hundreds of milliseconds, maybe it's a few seconds on the outset. When you start getting into like the 30-second time frame, that's really a whole different ballpark. Now, if that's something you want to do and you want to run Spring applications and you say, I get a lot of benefit out of that, and why can't I just run an App Engine? You can. We actually, I think a year ago or so, we introduced some extra knobs on the admin console specifically for these users. What you'll need to do is go into the admin console, make sure you enable billing, because that exposes all the knobs that we have, and then go into your application settings. And there's a couple of settings around min-max idle instances, min-max pending request latency, and those allow you to kind of tune the cost performance of your application. So if you have long loading requests and you just need to keep in a few extra instances around to make sure you can handle those spikes, even though you have long instances, you can actually crank up the min idle instances. On the other hand, if you're a fast starting app and you're very cost sensitive, there's ways to tune it kind of the other direction. We recommend everyone start out with the automatic settings, but we do have some special knobs for that. And I'm sure Matt in his talk will go into a lot more detail than we did right here.
Yeah, definitely.
Specifically around Java applications. So that's definitely something we care about, and we'll have some advice for you.
Yeah, that's great. Really good. Excellent advice. Oh, you've only got one question.
I've got one. And then we have a few more that came up in the moderator since we looked at these yesterday.
Now let me ask you a question.
Okay, go for it.
How popular is Google App Engine for Java? Most examples seem to be written for Google App Engine Python.
I hope that's not the case as far as the sample mismatch. It is true that we launched App Engine Python a year before the Java runtime. So in 2008 was Python, and then in 2009 we added the Java runtime, and later we added Go. So there may be just a little bit of bias still left in the system. So that because we originally set out to just have a Java runtime, or sorry, Python. But I think things are fairly evened out. If you go to the Google Cloud Platform user on GitHub, there's many samples there. There's Java and Python samples. Documentation, there should be samples in both languages. I don't recall the exact kind of popularity, but I thought it was fairly even. It may be a 60-40 split or something like that, with some percentage going to Go. Yep. But you shouldn't feel like Java's an underappreciated language on App Engine. It's definitely not the case. And if you look at the talks at I/O, you'll then see our focus on Java users and making sure they have just as good experience as Python.
Okay, that's excellent.
So pick the language that's good for you.
Yeah, definitely. Yeah, absolutely good advice. You got one more?
Okay, I do. Okay. So the App Engine documentation is incomplete. For example, the NDB docs, so NDB is a Python library for the data store, remain minimal and rarely document possible errors. Anything you can do about this? Or is there other places I should be looking?
Well, I guess really one of the standard answers for this is to go to Stack Overflow. You're going to find documentation, people talking about things that are undocumented or not so well documented, providing examples and such like on Stack Overflow. Pretty much everything anybody's tried to do is going to be documented on Stack Overflow. Things that have worked, things that haven't worked, so you can probably find good answers there. If you want to contribute information as well, Stack Overflow is not just for questions, it's also for sharing information as well. So if you actually have some useful information, something you've written about, something you documented, you can share that on Stack Overflow as well. Yep. I think that'd be a good place to put it. And it also stops it from being spread around everywhere. I mean, we could have multiple places where people could go to find different documentation. So that kind of ad hoc documentation really probably is best placed in Stack Overflow.
Yep. I kind of think of the App Engine core documentation as kind of the reference material, the baseline. Yeah. Sometimes there's JavaDoc or PyDoc to the methods that may help a little bit further. But some of these, like how do I use this specifically, Stack Overflow is a great place to go. And we do sometimes, if we find that there's a lot of questions around a particular area in Stack Overflow, we do go and update the documentation and maybe add some clarification. Right. So that's definitely a place to contribute.
Yeah, definitely. Excellent. Okay. All right, so question for you.
All right.
Okay, I'm going to read this through first. So I know what I'm asking. I've developed an application, 12 man-months, but today I have difficulties to set up the IT strategy related to the maintenance of the source code. Taking into account the amount of releases of Google App Engine Python, do you have any advice?
Okay. If I remember right, I think you were sort of suggesting the person who asked this question, they asked a few more questions, and I think you said it looked like they were maybe running Python 2.5.
Yeah, exactly.
Yeah. So App Engine has a deprecation policy on all of our production services of, I believe it's 1 year, and that's kind of our guarantee to you that we're not just going to change APIs on you. That when we bump up the next version of the application, your application is going to continue working. The APIs are going to behave the way that they expected. Having said that, there are kind of incremental changes that we make. Just like the Python language is Python 2.5 is not as common anymore as Python 2.7. At some point you need to make a switch. It should certainly not be a regular burden. I have applications that I deployed more than a year ago, and they're still running just fine. That's the experience of most of our users. Usually what we find is that developers are making changes because they want to take advantage of new APIs or new capabilities that we've launched.
Okay.
There have been probably a couple of cases where we've sort of had a changing, or not a breaking API change, but a new version of a capability that we've made available, and that's from Python 2.5 to 2.7. There are some differences, and Python 2.7 provides a lot of great features that weren't just possible in 2.5, like the ability to handle concurrent requests. There's many language preferences. We also had to change from the master-slave data store to the high-replication data store, which has huge advantages. The master-slave data store had regular maintenance periods. There's still a few users on that, but I believe the majority of users are now on the high-replication data store. Just a much better experience. When you commit your data, it gets committed to multiple data centers synchronously. When a data center goes down, you don't even notice it.
Right.
And that sort of improvement is sometimes worth going through the effort and making sure that the way you're executing queries is still compatible with the new version. But you have plenty of time to kind of make that change on your schedule.
Yep.
And so what we find that developers do is they sort of use one version of the SDK they're developing locally. They go through a couple of releases on their own, and then there's kind of a break, maybe once a quarter or so. They say, you know what, let's catch up to the latest features. Let's see what we can incorporate that we haven't yet, and then they'll kind of bump up the version.
Right.
And so you should have sort of naturally flow along with the App Engine releases.
Okay, it's important to also stress what we mentioned earlier. Experimental features are always likely to change from one release to another. So if you are using an experimental feature, it's probably you'll probably get enormous benefit just from using that feature. But you may have to adjust your code when we release a new version just to keep up to speed with it. Hopefully that's not a big impact though, not something that
it's generally a polish around the edges. When it's an experimental, or we're still trying to collect kind of feedback from the community, find out new use cases. Maybe there's ways that we could improve the API a little bit. And so you've seen that, for example, with the search API, that from the very early days to now, there's a couple of changes, but generally things have just gotten better, and all of our users have been quite happy with that.
Right, excellent. Okay. So we've got two more questions here.
Okay.
You can ask me that one if you like.
Okay. Well, I have a couple here too. I can ask you.
Yeah, we can do that.
Let's
Okay.
see.
You can put me on the spot now.
I am. Let's see. Please share tips on rate limiting requests without having to hit the data store. A memcache-based counter could work, but item expiry time is a little bit unpredictable. How would you go about kind of rate limiting individual users?
Interesting. I don't know. That's probably the kind of thing that I've not actually run across yet, so I'm going to punt that one to you as well.
Okay. Well, I think the person here suggested a really good place to start, which is the memcache-based counter. Memcache is using a least recently used or an LRU-based cache,
Yep.
and that means that the users that are most kind of heavily accessing your application, those memcache keys are more likely to actually be in the cache,
Yep.
and those that haven't been around a while, they're further down the list, and those will expire. So you sort of naturally get the keys that you care about most recent in memory. If you're looking at maybe even more aggressive throttling, where maybe you have some abusive users and you really want to kind of cap that behavior down, you can kind of take it up a notch and do some throttling within the instance. So you could introduce a data structure, a global static variable, in your code that for each App Engine instance kind of keeps track of like the hot users or users recently seen, and maybe throttles those individually. And then if there's a miss there, then you go to memcache. And what you're doing is you're just taking up another tier. You have kind of at the bottom you have the data store where there's transactions happening, and there's this limit of one transaction per second that you want to deal with per entity group. Then memcache, you can go much faster, and then in the instance cache, you can go even faster because you're just in memory. There's no cross network call to be made.
Okay.
So yeah, I think memcache is a great place to get started, and do instance caching if you need to there as well. All right, you had another one you said?
I do indeed, yeah. Last one from the list. We have a few more though there.
Okay.
So for GAE Java, there are detailed documentation for low-level data store API. However, fewer and incomplete documentation for how to map entity relationships with JDO JPA. Data nucleus is detailed, however, no easy way to tell if GAE supports the feature. So there's a question there somewhere.
Yeah, so the question is really, I think, around the, getting to the full details and capabilities of JDO and JPA on App Engine. Right. Maybe I should put this a little bit in context. When we launched the Java runtime on App Engine, we looked at kind of the active frameworks and abstractions that people were using. JDO and JPA were very popular, and so we did a lot of work to make sure that those were properly supported in App Engine. We also felt like users really benefited from SQL-like language, and so we launched GQL as a kind of a way of accessing the data store. And what we found over time actually is that developers, after a little while, feel much more productive when they're kind of working much closer with kind of the low-level APIs of App Engine or some abstraction that sits on top of those low-level APIs. So in the case of Python, we had the low-level Python data store. We've now iterated on that, and we have NDB, the new database model, which is sort of the way that we wish we had written it the first time, with memcache built in, and a lot, just usability is a lot better. On the Java side, we've actually had the community step up and produce an ORM framework called Objectify. Okay. And there's others out there. There's a developer in Japan who created something called Slim3. It's another abstraction layer for Java. And they do a really good job of sort of abstracting away the data store a little bit, but still staying very close to kind of the native performance characteristics, doing things kind of the right way. Objectify, I know, also has memcache built in, and it just lets you work with POJOs, so plain old Java objects. So you have a Java object with a bunch of properties, getters and setters. You can just take that object, you can push it in the data store, get it right back out. And that feels a lot more natural working in App Engine than the JDO and JPA. And so the way to kind of look at those technologies right now is, if you're a big JDO JPA fan, or you just use those in your environment and you'd like to, please continue to use them. They're there for you. But if you're kind of new to App Engine or you're at all unfamiliar about JDO and JPA, by all means, use either the low-level APIs or something like Objectify in Java, because you'll just have a much better experience. And those were written from the ground up for App Engine. Whereas JDO and JPA were written in a world where SQL was king. Yep. And it's a little bit of an unnatural fit. We got that square peg into the round hole, but we had to use a hammer a little bit, and so the corners are a little bit rounded off.
Okay, I come from a Java EE background, so I used to have a very big hammer.
I'm just visualizing the big hammer right now. Let's see, a question here for you. The rate at which you can write the same entity group is limited to one entity group write per second. And that seems, this developer's writing, it seems really low. They're imagining a Facebook application with 200,000 daily active users, which means something like 20,000 concurrent users on peak. So they're kind of contrasting this. They say, well, on the one hand, I have 20,000 concurrent users all making requests at the very same moment, and you're telling me 1 per second? Yeah. Where's the disconnect?
I think it depends on what your entity group was actually developed to represent, and how extensive you've modeled it and the way you've modeled your data. If your entity group is really specific to the particular user that's making the call, then you won't really have to worry about it. 1 write per second will be perfectly adequate. But if you kind of sprawled it a bit and the entity group touches multiple users, then you're likely to have some contention on that entity group. And so you have multiple users banging away at it at the same time. So really it's best practices at modeling your entities that will actually avoid that kind of issue. So if you have 200,000 concurrent, 20,000 concurrent requests, you're likely to be accessing 20,000 different entity groups, and you won't have an issue.
And that should be fine. Yeah. You want to do 2 million concurrent users on 2 million different entity groups, that's absolutely fine.
Absolutely.
So, think about entity groups as, for the most part, your unit of transactionality.
Yep.
So if you need some data related to a given user, like a user and their achievements, for example, and you have those stored in 3 or 4 different entities, you can put them all in one entity group, and then the App Engine data store will make sure that you can only have one transaction in flight at a time for that entity group. So generally what we see is that each user becomes an entity group,
yeah.
or each order in an order entry system, or each customer in a CRM system becomes an entity group. We actually also have, we didn't have this initially, but we introduced this again about a year ago, something called cross entity group transactions, or XG transactions. And that allows you to transact up to 5 different entity groups in a single transaction.
Oh, okay. That's awesome.
So it used to be the case that, so before we had XG transactions, there was a little bit of this trade-off between I want to make my entity groups bigger because I want to do transactions, but I need to make them smaller to have the right throughput. And that was sometimes a challenge. There are in fact libraries that sprung up that try to figure out how to, the classic example is I have 2 bank accounts. I want to move $10 from this bank account to that bank account. I need to do that within a transaction. And if I deduct 10 here and then add 10 there and something goes wrong in the middle, the $10 has disappeared. Or if I add 10 first and then remove 10, I've created $10 out of nothing.
Oh, I like that one.
Yeah, well, let's do that one. With cross-entity group transactions, that's no longer a problem. You can actually, in a single transaction, make that change. So really, I think this is all about just structuring your data store in such a way that you do no more than one write per second. Another kind of a classic way that people run into this is they'll do something like they'll create a site counter. They want to know how many visitors came to the website.
Exactly.
Favorite example, right? And so every time a user comes into the website, they increment the counter. Yeah. And this is what you would do in a SQL database. You would, kind of increment a particular row in the data store.
Yeah.
And the problem is only one person at a time can update that one record, because that one record is on disk somewhere, and there's some server responsible for it. And it can only touch that record, one transaction at a time, and that's really limiting for the number of things you can count. And so, a typical strategy that you use for the App Engine data store is to create something called a sharding counter, sharded counter,
right,
where you partition the counter into multiple counters. So, instead of say one counter, you split it out and you say, okay, let's make 5 counters or 50, some number n that's configurable. And now every time someone comes to the website, I'm going to, at random, pick a number from 1 to 5, and then I'm going to update that counter. So say it's counter 3 this time. The next visitor comes in, oh, it's again counter 3. Oh, now it's counter 2. And you say, well, that's weird, because now your total page view count is split up around 5 different counters. But that's not a big deal, because you can easily select 5 numbers and add them together. This is a very easy task for a computer to do. Yeah. But by doing so, you've just increased the throughput of your web counter 5-fold. Right. If you need 50 transactions per second, you go 50-fold, plus a little bit buffer, so maybe you go 60, something like that. Yep. But it's very easy to shard your counter out as far as you need to go.
And there's actually examples on the website, isn't it?
Yeah, it's our article. Yeah. Yep. So with a little bit of data modeling, you can do as many concurrent users as you like, and hopefully you do a lot more than 20,000. Yep. But 20,000 is pretty awesome. I wish my website had it.
20,000 is pretty good, yeah. And I guess the message here really is avoid shared mutable state. I love shared mutable state as a saying. Every time you share state that's mutable, you're going to run into problems with concurrency. So just keep it isolated. And
if you do that, you're going to have a bad time.
You're going to have a bad time, absolutely.
Yeah. Do you want to ask me this one?
Definitely, yeah. This one I think everybody's interested to know. This person's asking the question, has read 10 different definitions of a front end versus a back end instance. Yeah. And they're still not really quite clear on what the difference is between front ends and back ends. Is that something you can explain to everybody?
Yeah. So we actually, you mentioned this in the introduction, sort of the 2 different notions of a back end. You talked about mobile backends for cloud endpoints, and then App Engine has this specific definition of what a front end is and what a back end is. And frankly, other customers have said that's confusing, and we found it a little bit limiting in what developers want to do with their applications. And so if you've been actually reading through the release notes carefully, you'll notice that we've already started talking about kind of a new way of classifying components in the application called servers. And what we're going to do is we're going to get rid of the two special cases, the front ends that do things one way, and the back ends who do things slightly differently. And we're just going to say you can have as many different types of servers as you want. You can call them front ends and back ends. Maybe one of them is your mobile API, and one is your admin API, and a third one is something experimental. Maybe you have a component that's text message processing, and another component that's like real-time interactive stuff, and a third one that's reports. Every application is different.
Right.
But when you get beyond kind of a trivial application, you often want to kind of logically split your application into pieces.
Yep.
You may want to deploy the different pieces separately, like your mobile backend that's handling all your mobile requests.
Yep.
Maybe you have a new version for that. And with this will allow you to see separate traffic graphs for each of your server versions.
Mm-hmm.
Your logs will be separated out. So your mobile backend logs and so your static image logs can be separate. So all of that's coming. Just check out the release notes. You'll see that. And just sort of forgive us for calling them front ends and back ends. We'll make that kind of go away. You have an application, you split it in logical pieces, and we'll allow you to configure the different pieces the way you want, whether you want different instance sizes, different logs, etc.
So things like what the front end has currently of auto-scaling, that will just be a property of a server instance.
Exactly. So you say,
of a type of server.
If I have a mobile backend, auto-scaling on. I have this batch backend where I'm only going to do certain administrative tasks. I actually only want one instance of the server running, and it's just going to be kind of crawling some database or doing some background work. And you can have variations in between.
Excellent. Yep. Okay.
So
good.
We're making it easier, and we're simplifying the terminology.
Fantastic. Thank you. So you did explain it.
I hope so. All right, question here. What are the best practices for migrating from Python DB to the Python NDB API?
Okay, so I've got a confession to make here.
Okay.
I'm a Java gal. I come from a Java background, so I don't really deal a huge amount with NDB, but I've actually looked at the documentation and it looks really cool, but I wouldn't know where to start.
Okay. Well, so I have been calling myself a Java guy, but in the last year and a half or so, I have to confess I've been becoming somewhat of a Python fan, and I've been taking my own projects and migrating them. So I think
Excellent.
I can say maybe a few words about this. First thing is you don't have to migrate all at once. If you have an application, you have many different Python classes, and you have models all over the place, you can actually migrate a class file at a time. You can migrate a model at a time. You can intermix the two APIs. And the good news is that along the way, you'll probably, if you've done things around memcache caching, there's a lot of code you can delete.
Okay.
Because NDB just does things for you. The syntax between the two is a little bit different. So one of the first things you might do is maybe go around hunting for, we have there's a cheat sheet I've seen that sort of has the DB way and the NDB way. And that in the beginning is very good for just like mapping, like, oh, I need to change this around and do this. But you'll find that they're very, very similar. And like I said, just do kind of one model at a time, one class at a time, test it, make sure it works, and then keep going. And maybe what you do is you start out with any new models that you create, do them in NDB. So you start to get really familiar with it, and then migrate your old stuff.
Right.
But like with any real-time application where you're always serving requests, think about ways of doing things incrementally rather than in one big step. I don't think there's really any other tips for people migrating.
What about people getting started? So like when you're starting out developing an application, an App Engine application using Python, is it immediately obvious in the documentation, such like when you're developing with DB and when you're developing with NDB? I mean, is it easy to get pushed down one path or the other?
you can accidentally flip between the two. Both are in the kind of the left nav of the documentation,
Okay.
But it's very clear in your code because in one case you're importing from Google App Engine ext db,
Yep.
and the other place you're doing ndb. So there's no confusion there.
Okay.
But yeah, I do find when I'm clicking around the documentation, I'm sometimes end up looking at the wrong one. But
Yep.
you'll get through that.
So I guess if people are reading books on app engine development that are Python based, they may be looking at older examples that use the DB, and probably worth spending some time, investing some time to actually look at the differences in how you would do that in NDB rather than actually just writing up the samples in DB code.
Absolutely, yeah. If you're building anything new, you should only be using NDB. The author who wrote both, basically, he rewrote it and said this is how it should have been done the first time. So I can see a future where DB is either deprecated or tucked away in the documentation for very few to find, and NDB is just the way you should be writing applications. And we've actually just been going through a process with our sample applications. So if you look on, again, GitHub on the Google Cloud Platform, hopefully right now all the samples have been updated to NDB.
Okay.
So if you want to kind of good samples of best practices and how to do that, definitely go to our GitHub page.
Excellent. Okay.
Let's see, we got another question here. What's the best strategy to respond to requests that probably take more than 60 seconds to process?
I think was that part of the question? So make a backend process to process the request. That's the best thing to do. So you can do these things out of band or almost from the actual request itself. So the user makes a request. You need to actually service that request within 60 seconds, otherwise you'll hit a deadline exceeded exception in both Java and Python runtimes. That's a request timeout that we have that's always in place for what we call front-end instances currently. There's no such limitation on back-end instances. So what Fred said about moving to the server model, if you choose to use a standard instance that's not using autoscale, those things won't apply. It won't automatically hit this request timeout. So the best thing to do is if you need to do heavy lifting within when working to answer a user request, you should find a way to do that asynchronously out of band from actually responding to the user. So long running task, you say user makes a request that will result in generating 100 emails to different people. What you need to do is return a request back, respond to the user pretty quickly,
Yep.
and offline do them in the background, the email processing using a backend instance.
Yep.
It doesn't need to be a backend instance. You can push it off to task queues, and then you can start using things like Compute Engine and such like to. Compute Engine has the ability to do pull requests using task queues, so you can use Compute Engine instances to service those requests as well. But yeah, basically take it away from the front end instances and push it into a background somewhere using a backend process or Compute Engine.
Yep. Task queues definitely the way to go. The pull queues you mentioned are great for working with external systems, like doing off-app engine work, like Compute Engine.
Yeah.
But you could really do it on a server that you have sitting in a rack in your office if you have some special processing that you need to do. And then push queues are a great way of enqueuing work asynchronously.
Okay.
And that those requests come back to your application as if it were traffic, but it's internal traffic. So App Engine will scale up and down if you create more requests. And then you have a 10-minute deadline instead of a 60-second. So you can easily make those long-running URL fetch calls or do more complex processing.
Okay.
Yep. All right. When a user uploads a photo, like a movie or an audio clip, how do you store it so it can be statically available to your application? So it looks like they'd rather not have a dynamic request handler. Yep. Where they have to handle the request and figure out what blob to serve or what file to serve. Yep. But how do you make it available statically so the user can always get to it without involving App Engine runtime?
So correct me if I'm wrong, but I guess you would probably define a directory, a place where you would actually store these photographs, other images, movies, that kind of blob data. And then you would make sure that you declare that folder, that directory, to be a static directory within the declaration of the application. And that way, all of that will be pushed to the edge and served by our edge servers.
Well, yeah, you could do that for predefined content. If you're doing dynamically uploaded content, though, you probably do that via Google Cloud Storage.
So basically storing in Google Cloud Storage, and then you can provide a URL back to the user. Can actually access it directly from Cloud Storage as opposed to going through your App Engine instances.
Exactly.
So
yep.
That's good. Yeah, good point. Yeah,
and we have a new Google Cloud Storage client library that you can find on the groups, and it's basically a new library for accessing Google Cloud Storage very easily and efficiently from App Engine.
Right.
So I'd probably use that to get the files into Cloud Storage, and then just like you said, serve the URLs directly to that.
That has the additional benefit of not actually hitting your instances, so you won't actually incur any costs because you'll be serving that data directly from Google Cloud Storage.
Yep, you're just paying for bandwidth, no CPU. Yep. If I build my startup on App Engine, will Google help me with publicity?
Well, I guess it depends how successful you are.
Depends how cool an idea you have.
Yeah.
You've probably seen a number of customers with interesting stories on the App Engine blog. I think if you came to us with a really cool story, just reach out. We love to tell these stories and share them with our users. So that's probably
Yeah, tell us about your applications. Tell us about all of the cool and interesting things you're doing, and we can look into it for you.
And also, I know you and I both do presentations. We often share kind of partner stories and things like that. So definitely tell us about them.
Yeah, definitely.
Love to feature them. Well, that was kind of the last question of our list. Looks like we got to pretty much everything. There was a couple that we kind of skipped over due to time. I want to thank all the viewers for visiting today. Send us more questions. If you really like this, let us know, because we can definitely do it again. I think it was fun kind of answering questions. Thank you, Mandy, for doing the presentation at the beginning. It was very helpful.
Thank you, Fred. Yeah. And don't forget Google I/O next week. Follow it as live if you possibly can. If the sessions you're interested in are actually being streamed live. If not, follow them on YouTube afterwards or on the Google I/O site. The links, as I say, are in the YouTube video of this recording. And also, if you can, participate in Google I/O Extended. So that's really one way of getting involved in Google I/O outside of the event itself.
Yeah. All right. Thank you.
Thank you so much. Cheers. Bye-bye.